Hello everyone, welcome to Network Jungles. Today we have talk about in detail manner of IPv4. Let's see. So what is IPv4? So IPv4 is the Internet Protocol version 4. It is the 32-bit address and it is also called logical addressing in the network field. In the OSI layer it can be represented as layer 3 address as well as network layer. Then it can be represented into decimal number systems, that is the 0 to 9. The radius pair of decimal number system is 10. Finally, it can be converted into binary number systems, that is the zeros and ones, because the any electronic equipment can understand only the binary number system. Here is the sample example of the IP address 192.168.1.100. Then submask is the 255.255.255.0 and the default gateway is the 192.168.1.1. Then DNS server. So I used the Google DNS server 8.8.8.8. Then alternate DNS server is the 8.8.4.4. In command prompt, you have to see the IP address of the example. How the data format in IPv4. Already discussed, IPv4 is the 32-bit address. So it can be divided into 4 portions. So the each portions cover the 8-bit of the IP address. The first portions cover the first 8-bit, then second portion cover the another 8-bit, then third portion cover the another 8-bit, then fourth portion cover the last 8-bit of the IP address. So the 4 into 8 equal to 32-bit address. Here is the sample example of the IPv4 address in the client machine 192.168.100. Then it is separated by a dot symbol. Then submask also, then default gateway, then DNS server. It can be separated by dot symbol. Here is the 192.168.1.100. It is the decimal format. It can be converted into binary format, that is the 11000000, then 0. How the data conversion between the decimal number system into binary number system. Let's see. Next, how the decimal format calculated in IPv4. Here in the first row, the radius pair of binary number system is 2, zeros and ones. Then each portions cover the 8-bit. So the range starting from 0 to 7. So 2 power 0 equal to 1, 2 power 1 equal to 2, 2 power 2 equal to 4, 2 power 3 equal to 8, likewise 2 power 7 equal to 128. So the summation of all the values is equal to 255. Like the sample example of the two values 192 and then 168. Here is the binary number systems 1 then the remaining bits are 0. Here the position can be represented as 1 into 128. So 1 into 128 equal to 128, then 1 into 64, then 64. So 32 into 0. So multiply by anything 0 is 0. So remaining bits are 0. So 128 plus 64 equal to 192. Likewise 168 the number system 1010 then 1000. So 1 into 128 128, 0 into 64 0, 1 into 32 32, 1 into 8 8. So 128 plus 32 160, 160 plus 8 168. This is the conversion between the decimal to binary number system. Here IPv4 can be classified into two types of categories. One is the private IP, another one is the public IP. So private IP can be used for the inside of the organization, that is the LAN network. It cannot be used for the outside of the internet. Then public IP. So public IP can be used for the outside of the internet. It cannot be used in the inside of the LAN network. It can be classified into 5 classes. So class A, class B, class C, class D, then class C. Class A, class B, class C can be used for the real-time usage for the internet. Then class D, class C is used for reserved for multicasting and research purpose. 127 is used for loopback address. Next we have talk about the public IP. So public IP can be provided by the internet service provider, which is managed by IANA. So IANA can cover the 5 regions in the world: Africa, Asia, Canada, Latin America, then Europe. So it can be used for the outside of the organization, that is the internet. Next, private IP. So private IP can be provided by the network admin, which is managed by internally. It can be used for the inside of the organization, that is the LAN network. It can be classified into three classes: Class A, Class B, Class C. So Class A cover the 10.0.0.0/8. Class B 172.16.0.0/16. Finally, Class C 192.160.0.0/24. Here 127 is the loopback address. Next one is the loopback private IP. So loopback private IP is the 172.0.0.1. It is used for testing the host machine, whether the TCP IP protocol is working fine in the host machine. For example, you have to ping space 172.0.0.1. It can replay the ping. Even the internet is not available on the host machine. Next one is the link local private IP. If the DHCP server is not found on the LAN network, it can assign the automatically self-assigned address on the host machine. That is the range 169.255.0.02, 169.255.255.254. Here is the Class A private IP address starting from 10.0.0.0 to 10.255.255.255. Here is the subnode is /8. Here is the two basic example of the Class A IPv4 address. So already told, IPv4 can be covered the 32-bit address. It can be separated by 8 bits. The first 8 bit cannot be changed because the subnet is /8. So the remaining portions out of 32, the first 8 portions can cover the network segment, then remaining portions can cover the host segment. The range starting from 0.0.02, 0.0.1 to 255.255.254. Then broadcast address is the 255.255.255. So the valid host address, it can be used for the any electronic equipments, that is the network equipment. Next, Class B private IP address. So the Class B private IP address starting from 172.16.0.0 to 172.31.255.255. Here is the subnet is /16. It can be used for the any subnet. Here I use it for the example of /24. So /24 means out of 32 bits, the first 24 bits are used for the network portions. Here, so 8 plus 8, so 8 plus 8 16, 16 plus 8 24. So the first 24 portion is the network address, then last 8 bit portions can cover the host machines. So it can be used starting from 0 to 255. Next one is the Class C private IP address. That range can be from 192.168.0.0 to 192.168.255.255. Here the subnet is /16. So that range can be from /16 to /30. It can be used any subnet based on the need. Here is the two example of Class C private IP address: 192.168.10.0/24. Then another example is the 192.160.50.0/24. Here is the /24. So the first 24 bits are cover the network portions, and the last 8 bits are cover the host portions. So 192.160.10. cover the network segment. It cannot be changed. But the host portion can be starting from 0 to 255. So 0 is the network address, 255 is the broadcast address. So the valid host address from 1 to 254. It can be used for the network devices. Let's talk about in detail manner of IPv4 header format. In the IPv4 header, in each row consists of 32 bits. So 1 byte equal to 8 bits, then 4 byte equal to 32 bits. So 32 bits can be represented in 4 bits. So the minimum value of the header is 20 bytes. So 5 into 4, 20. Here the additional information is the 40 bytes. So 20 plus 40 is equal to 60. So the minimum value of the header file value is 20 bytes and the maximum value is 60 bytes. Here is the data can cover the 20 bytes to 65,536 bytes. The first portion of the 4-bit can be represented as IPv4. The value of binary equivalent is 0100. Here the decimal value is 4. Next 4 bits can cover the header length. So the equivalent of binary number is 0101. Here the decimal equivalent is 5. Because the 5 row consists of the header length, it can cover the, in each row is the 4 bits. So 5 into 4, 20 bits. The minimum value of the header length is 20 bits and the maximum value is 60 bits. That is the option of 40 bits. It can be added in the future. Next one is the type of service. It can cover the 8 bits. So the first 3 bits are priority of data. And next is the total length. The length of the entire packet is header and data. The minimum value is 20 bit and the maximum value is 65,536 bytes. So 2 power 16 equal to 65,536. So next one is the identification. So it can cover the 16 bits. If the packet is too large, it can be segmented into different pieces and send the same ID for identification of the same packets. And if the packet is too small, it cannot be send the same ID. Next one is the flag. So flag covers the 3 bits. So 0 is used for result and 1 is used for no fragmentation. Then 2 is used for fragmentation. Another one is the fragment offset. Then it is used for fragmentation and reassemble if the packet is too large. And next one is the time to live. So it consists of 8 bits. So 2 power 8 equal to 256. If the packet goes to the router, it automatically decremented by 1. Here is the formula TTL minus 1. If the packet does not reach to the destination before the TTL value is expired. Next one is the protocol. The protocol is the data portion of the IP datagram, whether it is the TCP protocol or UDP protocol. So TCP protocol can be represented as 6, then UDP protocol can be represented as 17. And next one is the header checksum. So it is the 60 bits. Then it is used for error checking of the header format. If the packet arrives at the router, then it can calculate the checksum. If it is different, the packet will be discarded because the packet value is modified. Then 4th row. So the 4th row consists of 32-bit address. It is the source IP address who transmit the data. Next one is the destination IP address. It will also cover the 32-bit address. So who is the destination? So finally data. Let's see the real-time example of the IPv4 header format using Wireshark. Here. So Internet Protocol version 4. The first 4 bits can be represented as IPv4 protocol. So 0100. And then next another 4 bit can be represented as header length. So it can consist of the 5 rows. So 5 into 4 bits is equal to 20 bytes. In the binary form, it can be represented as 0101. Here is the type of service is not priorities. So the value is 0x00. Then another is the total length. It can cover the 16 bits. So the value of the total length is 119 bytes. Next one is the identification in the second row. So whether the packet is fragmentation or down fragmentation. Then another 3 bits can cover the flags. So 0 is the result bit, 1 is the down fragmentation, then 0 is the fragmentation. So if the packet value is too small, so the fragment offset value is 0. Then third row. So third row is the time to live. If the packet is reached to the router, it automatically decremented by 1. So time to live the packet value is 128. Next one is the protocol. So it is the TCP protocol. The value of the TCP protocol is 6. Next one is the header checksum. It can be added some value for verification. Then fourth row. So fourth row consists of the source IP address. It is the client machine 192.168.29.152. Let's here the source IP address 192.168.29.152. Here is the source IP address. Then destination IP address. So destination IP address is the client need to access the web server. So that is the 20.189.173.3. So you can see the destination IP address in net of state table. So 20.189.173.11. Here is the port number is 443. So it is the HTTPS. Thank you. I hope this video is useful for you. Thanks for watching video. Click the bell button to subscribe. Let's see you next jungle video.